Today's episode, we are still continuing with the sum of the n term of a linear sequence. Typical example is to find the sum of the terms under this sequence 1, 3, 5 up to 101. So finding the sum meaning we have to add all the numbers in the sequence, including the ones that have not been written. Now in doing this, we need to know the number of terms, meaning how many different elements are present in this series. Then we need to know the first term, which of course is 1, the common difference, then we can get the sum. If you are new to this, please consider subscribing to the channel, like and share. So as I said earlier on, we need that our sum is n over 2. Since we know the last term of the sequence, we use A plus L, where L stands for the last term in the sequence. So we need the first term, which we already know. The last term is known. The only thing left is a number of terms. So how do we get the number of terms? So we need to find that using the nth term of a sequence, which states that the nth term is A plus n minus 1d. This nth term is the same as what? The last term. So ignoring this side, we could still say the whole of this equals the last term, where our first term is going to be 1. Our common difference is going to be difference between 3 and 1 is 2. Likewise, difference between 5 and 3 is also what? 2. Then we know our last term as what? 101. So the only unknown quantity here is what? The n. So that can be found. So beginning with this will be 101 equals to 1 plus n minus 1 times what? 2, which is our common difference. So this can be open. So 101 equals to 1 plus 2 times n will be 2n minus 1 times 2 will be minus 2. So this is a variable. So constant and constant can be computed. So 101 equals to 1 minus 2. That will be minus 1. So 2n minus 1. So we can still move this constant to come here by adding 1 to both sides. 101 plus 1 equals to 2n. I believe per this calculation we have 102 equals to 2n. We are still looking for the n, so we divide through by 2, and that gives us n equals to 51, meaning the number of terms that are present in this sequence or series is going to be 51 different terms. If you keep on adding 2, which is the common difference, to each of the terms, to get to 101, you have to get 51 different terms. So now from here, the sum of all the 51 terms is going to be 51 over 2 multiplying 1 plus last term 100 and what? 1. So fast forward, 51 over 2 times this is going to be 100 and what? 2, as in adding this to this, we have 102, where 2 can also go there as well to give us 51 times what? 51. And that is going to be 25 plus this, so 26. That will be 0 and 1. So that will be 2,601. That will be our sum of all the terms. I believe you follow the steps involved in this. Similar questions can be given. The same approach can be used. If you follow this, please don't forget to share with your mate, like, and leave a comment. Bye-bye.